Very good evening all my dear. Jai Hind. I am Rakesh Chaubey from Sunbeam Sun City. My dear, today I am uploading the numericals topics on the topic is lateral shift. That is, in glass slab there is a lateral displacement, lateral shift, and normal shift or apparent shift. We have done the topics on real depth, apparent depth. So on that topic it is a normal shift or apparent shift, and the problem on lateral shift, that is based on glass slab lateral displacement. It is mixed problem, so my request that please go through with the problem carefully, and I'll try my level best to cover the NCERT problems first and some HOTS numerical also with respect to this topic. Now the topic is next video will be on total internal reflection. The next video, the numerical problem, is on TIR, total internal reflection. So the question is, a rectangular glass slab, I have written the sum numerical, a rectangular glass slab rests in the bottom of a trough of water. I have taken, this is a trough of water, you can see, and there is a rectangular glass slab taken in the bottom of the trough, right? A ray of light is incident on the water surface at an angle of 50 degree. So here I will draw a ray of light. Say this is a ray of light, and this is the ray of light. This is incident ray. This is in air, and it incident on the water surface. You can see here, I am drawing in front of you. So here it incident and it make an angle of 50 degree, that is I is equal to 50 degree. Now my dear, as soon as this light is incident here, making an angle of 50 degree, this will be, since the light coming from air to water, it will be bent towards the normal like this. And here is the angle R, you can say. This is the angle R in water. This is refraction angle in water. But my dear, my question is, calculate the angle of refraction in glass. Not the angle of refraction in water, but the angle of refraction in glass. So now my dear, here this ray, so it is bent towards the normal. I hope this is clear because it is from air to water, right? So air to water means air to denser, it will be bent towards the normal. Again here I have drawn the normal on the glass slab. You can see I have drawn the normal on the glass slab. And now this time, this is water and this is glass. You can see again, this is water and this is glass. Water has a refractive index. Mu of water is 4/3 given, that is 1.33, and mu of glass is 3/2, that is 1.5. Now my dear, looking to this two things, you are sure from the data, from the topic, that since mu of glass is greater than mu of water, so if mu of glass, because mu of glass is 1.5 and mu of water is 1.33, so mu of glass is greater, so it means this light in water is coming, water become a rarer medium and glass become denser medium, right? Because water ka mu is less and glass ka mu is more. So water is air and glass is denser. So this light which is traveling in water, this particular light which is traveling in water, when it will be go in glass, my dear, when it will be go in glass, it will be bent towards the normal. It will be bent towards the normal. You can see here is the normal. So here it will be bent towards the normal, and now I will put this as that the angle of refraction in glass is denoted by R dash. This is the angle of refraction in glass, that is R dash, and angle of refraction in water is R. So I hope it is clear, the diagram is clear to you all. See, here when it is coming from air to water, the light will bend towards the normal, and when it is coming from water to glass, again it will bend towards the normal. Why? Because water acts as a rarer medium and glass acts as a denser medium. Its Ri shows this. Because Ri of water is less and Ri of glass is more. So in this case, the water become rarer and glass become denser. So again this light which is traveling in water, this particular light will be bent towards the normal when it will be entered in the glass. I hope it is clear, because it is the case of rarer medium to denser medium. So this is the diagram, and here is the angle R, but this angle R is for water, and this is the refraction angle. This is the, I am drawing this is as a normal. This is the refraction angle I supposed to find. So from the figure, so here I will write from figure, R dash is supposed to calculate, that is angle of refraction in glass. Now my dear, here this is mu of water which is given, and this is mu of glass which is given here. This is mu of water and mu of glass. Let me tell you, the light entered in water, can't say, from air. So take care of this. Actually this is not only mu of water, this is mu of water with respect to air. Or you say this way, sir, this is mu of water which is given, that is 4/3, is actually mu of water, that is true, but it is with respect to air. This is Ri of water with respect to air. Please take care, this is the important case. Numerical they are giving mu of water, but my dear, water में जो light आया है, that is with respect to air. Even this is mu of glass which is they have calculated 3/2. It is with respect to air. So any mu data which is given in the numerical, that mu data is with respect to air. So here this is mu of water, it is given only in numerical this much. But you will take it as mu of water with respect to air is 4/3. Similarly, mu of glass with respect to air is 3/2. Therefore, my dear, mu of water, now where it is going? It is going in glass. And water into glass. So here I will write, since according to question AQ, the light passes through water into glass. So this is mu of where the light going. Please take care, where the light going? Light going in glass, and coming from where? It is coming from water. You can see it coming from water going in glass. So this can be written as mu of glass with respect to water. Now mu of glass with respect to water can be written as mu of glass upon mu of water. Mu of glass with respect to water can be written as mu of glass with respect to mu of water. Now this can be written as mu of glass with respect to air, mu of water with respect to air. This is more logical. Am I clear? Because you can see this is mu of glass upon mu of air, and here also mu of water upon mu of air. So ultimately answer is mu of glass upon mu of water. So that's what I wanted to say you all, that mu of glass with respect to air is mu of glass upon mu of air. So I can write this question as this way, this answer as this way, my dear. Therefore, mu of glass with respect to air is mu g by mu a, and that is equal to 3 by 2. Mu of water with respect to air is mu of water upon mu air. Please take care, I have done this all, is nothing but it is given as 4 by 3. So my dear, I will put this as equation 1 and I will put this as equation 2. So now I will say dividing 1 by 2, we get mu of glass upon mu of air whole divided by mu of water divided by mu of air is equal to 3 by 2 divided by 4 by 3. That is 3 by 2 into 3 by 4, that is 9 by 8. And mu of air cancel. So this will give me mu of glass upon mu of water. Or here I will write, this will give me mu of glass upon mu of water, and that can be called mu of glass with respect to water. So I got, my dear, mu of glass upon mu of air divided by mu of water divided by mu of air. I mean to say this refractive index which are given is not only mu of water, it is with respect to air. So यहाँ पे भी it is with respect to air. So with respect to air is ultimately cancel. So what is the answer I am getting? I am getting the answer for mu of glass upon mu of water. But mu of glass upon mu of water can be written as mu of glass with respect to water, because this can be written this way. So now my dear, therefore, so I got, therefore, mu of glass with respect to water is 9 by 8. Now my dear, after this, I got this mu of glass with respect to water. Now everybody know that there are two interface takes place. Why I am calculating mu of glass with respect to water? Because I have mu of water with respect to air. I have mu of glass with respect to air. Now the last interface, what? Glass and water. That is water and glass. And therefore I have calculated if finally light is going in glass. So I have calculated this Ri, that light going in glass, so mu of glass with respect to water is 9 by 8. So please try to understand what is the logic behind it, why did we calculated this. Now let's go to the next part. Now in the next part, my dear, so please note it down this much and then I will go further. So now my dear, if you can see, we have mu of glass with respect to air is 3 by 2. Mu of water with respect to air is 4 by 3. And mu of glass with respect to water is 9 by 8. These three things we have calculated right now. Okay, I hope it is clear. Mu of glass with respect to air was given, mu of water with respect to air was given. Only I have calculated mu of glass because finally the light going from glass through water, that is water into glass. Please take care. So I have calculated this. Now my dear, now from figure you can see there are two refraction taking place. One, the refraction is taking place on water surface. Say I have named it as AB, and other the refraction is taking place at glass surface. So there are two refraction taking place. One refraction is taking place at water surface. So let us take first water surface from figure. When refraction takes place on water surface, AB. So here the light traveling from air to water, that is light ray travel from air to water. So now what will be happen? Mu of water with respect to air, I am sure, because it is going in water coming from air. All my RI concept is required, neither otherwise you are not understood the sum. So it is travel from air to water, written as mu of water with respect to air, that is light going in water coming from air. So the angle of air will come in numerator. So in air the angle is I, so this is sin I, and in water the angle is R, so it is sin R by Snell's law. By Snell's law, because in air it is coming from air going in water, so in air the angle is I, so that angle will come in numerator, and in water where it is going, the light going in water, so the angle in water is R, because I am taking the refraction at water surface. Okay, same logic I will go when it is water to glass, same logic, but first I will complete this. So now here you all know that mu of water with respect to air is 4/3 is equal to sine of, it is I is 50 degree divided by sine R. Therefore this will be sine R is equal to sine 50, you can see sine 50, and this 4/3 will come in here. So this is 3 sine 50 divided by 4. 3 will go up, 3 sine 50 divided by 4. My dear, the sine 50 is nothing but, here I am writing, sine R is equal to, I am giving you, sine 50 is equal to 0.766. 0.7660. This is the value of sine 50, suppose it is given. In your exam, don't worry about this value. These values will be given to you, or you can see from the log book, from the log table. Sine 50, all these value either they are giving in the exam or they have to see from the log book. So don't worry about these values and all. So this is 3/4 into 0.7660. So this will give me sine R is equal to 2.2980 divided by 4. That is 0.45 4 sevens are, I hope it is clear, and then 4 threes are, 4 fours are, 4 fives are. We will get 0.5745. So now this will give me, my dear, sine R is equal to 0.5745. Therefore R is equal to sine inverse of 0.5745, and the angle, this also is given in the exam. This value is also given from log book. From log book, we observe sine inverse of 0.5745 is 35 degree, 35.606 degree. It is 35.06 degree. So here, my dear, therefore R is equal to 35.06 degree. But my dear, this is the angle of refraction. This is angle of refraction in water. And I have to calculate the angle of refraction in glass. So now let's go to the next one. So now, my dear, we calculated angle of refraction. Thus, angle of refraction that is angle R in water is 35.06 degree. We have calculated. Now here one point I wanted to say. Now this is the angle of refraction in water. You can see. Everybody can see the angle of refraction in water is this. That is R, which is answer is 35.06 degree. Now my dear, this angle of refraction in water become angle of incident here, because this angle R in water become angle of incident in glass. For incident, it will be incident angle for the glass, because alternate angle. Here I can draw this. This is the glass, and here is the angle coming. This is the alternate angle here, and this angle are equal. So if this is R, this is also R. You can see my figure. I am drawing here, my dear, to show you here, so that there should not be any confusion. So here, if this is a glass slab and here is the light coming in water, this is your water. This is your glass slab. Now here, my dear, the angle is R. So if this will be fall here as a normal, so this is your also R by alternate angle. So here, therefore, when refraction takes place this is I am writing figure 2, you can see, takes place from glass surface. When refraction takes place from glass surface, my dear, then angle R is equal to angle I dash. I will put this as I dash from figure 2. Angle R is equal to angle I dash. You can see I have cut this much figure and I have drawn here. Please see it, because this line and this line is parallel. So R and I dash become equal. So now again by using Snell's law, when light travel from water to glass, earlier it was air to water, now it is water to glass, mu of where it is going in glass, so mu of glass from where it is coming, water, mu of water, and this is equal to what angle is made in water? The angle made in water is I. You can see that is sine I dash. The angle made in water, which is incident angle, here is a water, this is all water. So here it is, I am writing here I dash so this is here is an angle, and this angle is I dash. Here I have drawn. So at water glass interface, the angle of incidence is I dash. So this is sine I dash sine I dash, and that I dash and this R are equal, right? I have drawn in the figure. So sine I dash divided by sine r dash, because angle made in glass is r dash and angle made in water when it is coming from water to a glass is I dash. You can see in the figure. You can see in the figure it is I dash. So sin I dash, because कहाँ से आ रहा है? Water से आ रहा है. So angle is sin I dash divided by sin R dash. Because water में the angle is I dash and glass में the angle is R dash. So now this is my dear, this is sin I dash, since I dash is equal to angle R and that is equal to 35.06 degree. So this is sine of 35.06 degree divided by sine of R dash, and this you all know that this is 9 by 8, because we have written 9 by 8 is equal to sine of 35.06 degree divided by sine R dash. Therefore sine R dash is equal to, you can see, sine of 35.06 whole divided by 9 by 8. Therefore this is sine R dash is equal to 0.575. I hope it is clear. The earlier it was 0.5745, because you all know sine of 35.06 is 0.5745. Earlier we did it. Divide by 0.5745 divided by 9 by 8. This will be nothing but 8 into 0.5745 divided by 9. And this will give me, my dear, 8 5s are 40, 8 4s are 32 and 4 6, 8 7s are 56 and 6, 8 5s are 40 and 6 46. That is 4.6260 divided by 9. So this will give me, my dear, I hope this is the last part which you are getting. This is sine R dash is equal to 0.9 5s, 9 1s. I hope it is clear, because 9 5s are 45, 1 and 9 4s. So this will give me 0.51. I am sure the answer is 0.5140 is sine R dash. So now R dash is equal to, this is 8 by 9, 0.5745. It is 0.51707, I hope. Sorry. Once again. 9 5s are 8 5s are 40, 8 4s are 32 and 6, 8 7s are 56 and 3. 60. 8 5s are 40. This will be the answer. So 0.9 5s are, and this is 45, 9 1s are, and then it is 1 6. So it is 06 or 07. I hope it is clear. 8 5s are 40, 8 4s are 32 and 4 36, 8 7s are 56 and 3, 56 and 3 59, and 8 5s are 40 and 5. This is 4.5960. Now if I can go for it, 0.51 and 07. Yeah. This is 9 6 are 54. You can see 07, because recurring 666 will come. Therefore this is, my dear, therefore this is R dash is equal to sine inverse 0.5107, and the answer of this you all know, because 0.5 is almost 30 degree. So 0.5107 is nothing but, my dear, this is 30 point, the answer is 30.7 degree. The answer is 30.7 degree. I hope it is clear with the question that an R dash is the angle of refraction in glass. So that's what my question is. That is the R dash and this is the angle of refraction in glass. So we have calculated this is the sum which is based on the topic for the going for the deviations from a three interface, that is air, water and glass. Now my dear, the next problem based on lateral shift. The question is a ray of light is incident at an angle of 60 degree. Matlab it is coming from air. It is not given but you should say understand because I have not mentioned any medium. A ray of light is incident at an angle of 60 degree on one face of a rectangular glass slab of thickness 0.1 meter. And refractive index is 1.5, but this is a refractive index of glass is 1.5. Calculate the lateral shift produced in the glass slab. So what is the data given? Angle I is 60 degree, thickness of the glass slab is 0.1 meter, and here mu of glass, here is mu of glass. But the light coming from, no doubt it is coming from air. So you will write this way, please. Make an habit of writing this way. This will help you a lot. This is mu of glass with respect to air. Just you will write mu of glass. It will not click any formula. So better it's my request. I'll show you. See how it's clicking the formula. This much is clicking the formula. So mu of glass with respect to air is 1.5. My request. Lateral shift is given by x. Say I have mentioned it x and I am supposed to calculate x. Now my dear, the formula for lateral shift, it is a formula based question, simple formula based question. Don't leave such numerical. This is x is equal to, this is t by cos r sine of I minus r. This is the formula my dear. The formula for lateral shift is t by cos r into sine of I minus r. This is the formula my dear, you can see in front of you everybody. Now my dear, looking to the data given, I hope everything is given. T is given, I is given, right? But r is not known. Unless and until I calculate r, so let us calculate r. So how I will calculate r? According to this, since mu of glass with respect to air is given. That's what I said. Don't write only mu of glass. Otherwise you will not get the formula. So mu of glass with respect to air, it's coming from where? Air. Which angle is made in air? I. So this is sin I divided by sin r and this is by Snell's law. So this will be my dear 1.5 is equal to sine of 60 divided by sine r. So sine r is equal to sine 60 divided by 1.5, that is root 3 by 2 into 1.5 will become root 3 by 3. So sine r is equal to 1.732 divided by 3, because root 3 is 1.732. So this will be 3 5s are 0.5773. Therefore, R is equal to sine inverse of 0.5773. You don't worry about this part. My dear, these values are given in the book or by logbook you will calculate. I will get R is equal to I got R is equal to 35 degrees 16 minutes by log table. When I search 0.5773 sine inverse of that, I got the answer. R is equal to 35 degree 16 minute. Now my dear, I will substitute this R in the formula of lateral shift and it will give me, so now X is equal to, this is T cos R into sine of I minus R. This is X is equal to T is 0.1. Cos R is cos 35 degree 16 minute. You can see into sine of 60 minus 35 degree 16 minute. Now my dear, when you are subtracting degrees, there is some rule. You all know that since, look at this, 60 degree can be written as 59 degree 60 minute. 60 degree can be written as 59 degree 60. So this is 60 degree is 59 degree 60 minute, because 60 minute is 1 degree. So 59 degree and 60 minute ka 1 degree become 59 degree and 1 degree 60 degree. Why I have written? Because I have to subtract 60 degree mein se 35 degree 16 minute. But here there is no minute. So I have written 59 degree 60 minute, and then so here it is 35 degree 16 minute to be minus, to be subtract. So now this will be 44 minute, and 59 minus 35 is 24 degree. So here my dear, this will be X is equal to 0.1 upon cos of 35 degree 16 minute into sine of 24 degree 44 minute. And I have shown that how it is 24 degree 44 minute in my calculation, because 60 degree can be written as 59 degree 60 minute. 60 मिनट का 1 डिग्री होता है, so 59 डिग्री और 1 डिग्री मिलकर 60 डिग्री हो गया. अब मिनट होने के वजह से I can easily subtract this. So now my dear, X is equal to, this is 0.1 into sine of 24 degree 44 minute is 0.4184. Don't worry about this part. Again I will get it by logbook or by log table. By log table I got this value, and cos of 35 degree 16 minute is 0.8164. Again this value I am getting by the log table. Okay, so now my dear, this is X is equal to, when I solve this all, the answer for this will be 0.0513 meter. On solving this, we will get the answer 0.0513 meter. This is the lateral shift produced in the glass. So my dear, this is the question. I hope you all understood. So please, this is what is the important concepts: an array of glass given, array of water given. Please put it with respect to air, so that will help air. Here it will help you to put the Snell's law. Only if you write glass, my dear, you will not click a Snell's law. Snell's law click nahi hoga. But when you write air, immediately you will click. Oh God, the light coming from air going in glass. So according to Snell's, the light coming from air, so angle of incident will come. Air ka angle will come first. So air mein it is making angle of incident 60 degree. So the formula will become sin I divided by sin R. That is angle made in air divided by angle made in glass. So angle made in air is I and angle made in glass is R. That Snell's law will come to know, and this will help us to calculate the refraction angle in glass. And through that we can calculate the lateral shift. So I hope you understood. Now in the next video I will upload the more numerical on the normal shift and apparent shift.